Hi everyone, this is Big Face back with part 8 of the desktop robot head and arm build. If you remember from the last video, I was trying to figure out the best way to get some feedback from the servo with the sonar mounted on it. I got brave, I took the mini servo apart and added a connection into the internal potentiometer as I have with the other servos, so I could get some feedback position for that one. And then I added this into the 3D model of the robot arm. The next step of this project was to start logging the sonar readings in 3D XYZ coordinates using the arm model to help with this, and put these into a big array and start building up a map of the environment. I did this and it worked quite well, just manually moving the arm around and taking these readings at set intervals. And I'll show you a bit of footage here of some of the early point clouds displayed in a matplotlib 3D plot, and these had a couple of hundred data points. I wanted to take this a step further and have the robot run through a sequence of positions and log a sonar reading at each of these predefined positions. And I took this as far as I was willing to, and programmed the robot to move to around 3,000 to 4,000 different positions as it scanned the environment to build up a fairly decent sized point cloud, which you saw in the introduction to this video. I'll show some footage here of the robot replaying these predefined sequences to gather the data. As you can see, I put the robot face in a wall and a bit of board or a bit of aluminium plate that I put up just to give an artificial corner for the robot to scan, and it went through these sequences and probably took around 30 to 40 minutes to complete the total sequence. So if we look at the 3D plot on the screen, you can see that the objects close to the robot are picked up in reasonable detail, with the sort of resolution getting worse as the objects are further away, just due to the geometry of the robot and the way the sonar is picking these objects up. So I was pleased with the point cloud, and it proved a concept that the robot could do it, and the sonar readings were coming back quite accurately and reliably. This isn't the ideal solution to the problem I'm trying to solve, and that is the robot being able to locate itself in space and identify any changes in its environment. So I took this as far as I can. I'm quite pleased with it, but I'm going to make some changes to the robot and the way I'm doing things to try and get back on track with the ultimate goal. So as you can see, a couple of minor hardware changes, and that is putting the hand switch back onto the robot arm and moving the sonar sensor over to the robot head. I made a very quick bracket just to attach that temporarily to the top of the robot head, and I'm currently working on identifying objects of interest with the camera using OpenCV and trying to get a very estimated range to that object using the sonar. The hope is that I can log an object type and place it roughly in 3D space. That way, next time the robot's looking around and it sees an object, it can look up where it's seen that size, shape, colour of object before, get a rough range to it, and locate that object relative to itself. And once I've built up a map of various different types of that object, it can use those as references as well. So for a minute, this is how the robot's going to look. I may put the arm on hold for a minute and then go back to focusing on the head. And whilst this robot design has served me well and I've made some good progress, I am itching to get back on the 3D printer and the milling machine and do some hardware changes. So I may actually be starting a new design robot head very soon, and I might actually simplify the whole thing and just go back to a simple pan and tilt 2 servo arrangement, but make something that looks a bit more aesthetically pleasing perhaps. I may not use the screen to display a face. I've got some RGB LEDs that might make some nice looking eyes that can convey some emotions as well. Maybe I use the screen somewhere else in the project, so keep an eye out for that coming up. And I'm going to stick with what I got for a minute and try and implement what I've just talked about, and using the camera combined with the sonar sensor, and I'll let you know how that goes. So keep an eye out, and until next time, thanks for watching.